I'm Anil Kumar. Here is an excellent example on finding limit of indeterminate powers. We are going to use L'Hopital's rule to find the limit. The question is, find limit as x approaches infinity for 1 plus 2 over x plus 4 over x squared to the power of x, right? This is to the power of x, okay. So let me rewrite this. We have 1 plus 2 over x plus 4 over x squared, right? So that's the question. You can pause the video, answer the question, and then look into my suggestions. Now in this case, if I substitute x as infinity, we get 1 here to the power of infinity. So basically it is 1 to the power of infinity. That is the indeterminate power. So we can apply L'Hopital's rule. Now whenever you have this kind of situation, there are two approaches to this. One, you could write this as an exponential equation, or you could write this as logarithmic equation. I prefer to use the logarithmic equation, which we'll discuss in this particular video. So we begin by writing the function as a variable y, for example. So y is equals to 1 plus 2 over x plus 4 over x squared to the power of x, right? If I take natural log on both sides, that is ln y equals to x times ln of all this, which is 1 plus 2 over x plus 4 over x squared. We really need to find the limit, right? So the question is to find limit for the function as x approaches infinity, and the function for us is ln y. So instead of y, we'll find limit for ln y, and later we know we can always write y equals to e to the power of ln y, right? So the concept here is that the limit as x approaches infinity for y is equals to limit of this thing, right? X approaches infinity for ln y. Is it okay? So once we get this limit, we will get our answer as e to the power of something. So this is just give you heads up. Okay. Now another important thing here is that whenever you're applying L'Hopital's rule, you have to write quotient of functions. So you should always keep the complicated function on the numerator. In our case it is ln. So ln 1 plus 2 over x plus 4 over x squared comes in the numerator, and the denominator will be reciprocal of x, right? So that is how we have a format here. If I substitute, we have limit x approaches infinity. So if I substitute infinity here, I get 1 over infinity, which is 0. And we get ln 1. ln 1 is also 0, right? ln 1 is 0. So we have a form 0 over 0. So we can now apply L'Hopital's rule, which is that the limit of quotient of functions is same as limit of quotient of their derivatives, right? So I'm saving a step, not writing derivative of numerator and derivative of denominator, but I'll straight away write down their derivatives, okay? So derivative of this function is 1 over all this, which is 1 plus 2 over x plus 4 over x squared times derivative of this function. Now derivative of 1 is 0, and this is minus 2 over x squared, and this is minus 4 2x over x to the power of 4. So we could write this as minus 8 over x cubed, okay? So that is the derivative of this function, right? So that times this comes in the numerator, and the denominator for us will be derivative of 1 over x, which is minus 1 over x squared. Is it okay? So that is how we get the quotient of their limits. Okay. Now we can continue. Sorry, this is approaching infinity. It should have been infinity. Okay. So we'll continue, kind of simplify this a bit. Okay, so we have limit x approaches infinity. Now I'll take this minus x squared in the numerator, so we'll kind of get rid of one layer of fractions, right? Okay, so what we get here is we have 1 over this term, which is 1 plus 2 over x plus 4 over x squared times this term. Now since this, okay, minus and minus will become positive, let me take minus. Okay, no problems. So what we have here is minus 2 over x squared minus 8 over x cubed, right, times minus x squared, right? So we'll do minus x squared. Is it okay? Like this. Now the idea of going through these steps one by one is for you to appreciate how really to solve this, right? Simplify. These algebraic operations can be very tricky at times. Okay, so go through them and understand what we are doing. So let's move on to the right side. So what we have here is limit x approaches infinity for ln y is equal to all this. Now if I multiply, then x squared and x squared will cancel. Minus becomes positive. This also becomes positive, right? So I can write this as limit x approaches infinity. So the numerator will be 2, right? So because x square cancel, negative negative becomes positive. In this case, it becomes positive 8 over x, right? So plus 8 over x divided by all this, right? So divided by all this, correct? And this is 1 plus 2 over x plus 4 over x square, right? So that is what we get. Now we can substitute infinity here. So 8 over infinity will be 0. So we are left with 2 here, right? In the denominator, 2 over x, x is infinity, 4 over x squared, x is infinity. These two terms are again 0. So we get 2 over 1 or 2. So what we have got here is that the limit x approaches infinity for ln y is 2. Okay. Now as you understand, we could write y as e to the power of ln y, right? That is how we can write. And if we take limit as x approaches infinity, it will be limit of this, right, as e to the power of limit x approaches infinity of ln y. So y is this function. So we can write limit as x approaches infinity for the given function, which is y for us, 1 plus 2 over x plus 4 over x squared to the power of x is equal to e to the power of this limit. And this limit we just found as 2. So we can write this as e squared, right? So e squared. You get the idea, right? So once you do this and you get limit for ln y, then the limit for the function will be e to the power of that answer, e to the power of that answer, right? And here is how. There is how. This is the theory behind it, correct? So we get e squared as the limit of the given function in our case. I'm Anil Kumar. You can always share and subscribe my videos. This is a very important question. I'd like you to go through it once again and do related questions as practice. Thank you and all the best.